Okay, this is the third and the final video segment for the solution to homework 14. I'm going to be doing number 36. Number 36 actually is very similar to 35, and if you got dizzy when I did number 35, now here's another chance. Cotangent of x plus y equal to cotangent of x plus 1, cotangent of x. Let's clean this up. Cotangent of x, cotangent of y, minus 1 over cotangent of x plus cotangent of y. Now, my approach, we're supposed to prove this. My approach is to start from the left-hand side and go to the right-hand side, okay? There are other ways of doing it. For example, you can start simultaneously work on both sides. You can start from the right and go to the left. So you know what? This time, instead of approaching 35, I'll do it a different way. Approach in 35, number 35, I'll do it a different way. Do it differently. I suggest you follow the same approach and as in 35 and make sure you can get it. I'll start with the right-hand side, okay? Now the right-hand side looks like this. Cotangent of x, cotangent of y, minus 1 over cotangent of x plus cotangent of y. So what I'm going to do is I'm going to write these in terms of tangent. So 1 over tan x, 1 over tan y, minus 1 divided 1 over tan x plus 1 over tan y. So the common denominator is tan x, tan y, and up in the numerator I have 1 minus tan x, tan y. And down here the common denominator is tan x, tan y, and over here we have tan y plus tan x, or tan x plus tan y. It really doesn't matter. Now notice that these two cancel each other out using basic laws of arithmetic, or 1 minus tan x tan y divided by tan y, or I'll write tan x first, tan x plus tan y. And I'm going to write this thing as 1 over tan x plus tan y divided by 1 minus tan x tan y. I hope that you can see that. I hope you see that these are the same. And if you don't, come and see me, talk to a friend, go to the math lab, seek some help. That denominator is simply tan of x plus y. And this is cotangent of x plus y, which is your left-hand side. So my advice to you is you try this using, well, first this way, then the way I did number 35, and then go and repeat number 35, trying to do it the way I've done it here, okay? No pain, no gain. Okay, number 37. Prove tan x minus tan y equal to sine x minus y over cosine x over cosine x cosine y. Okay, so I'm going to start with the right-hand side, more force my way to the left side. So that's going to be sine of x minus y divided by cos x cos y. Now we have a way of writing this thing in terms of the formula that we have seen. Sine x cos y minus cos x sine y, cos x sine y divided by cos x cos y. Now, I want to remind you basic laws of arithmetic. You can do this over that minus this over the bottom. So this is equal to sine x cos y over cos x cos y minus cos x sine y over cos x cos y. Now let's cancel the stuff that we can. This cancels that, and this cancels this. This is going to be sine x over cos y, cos x minus sine y over cos y, and this is tan x minus tan y, which is your left hand side right there. That takes care of this. Let's go to number 59. This is the last block. It says express the function in terms of sine only and then graph it. So you're told that g of x is equal to cosine of 2x plus, right there, plus root 3 sine of 2x. It says write this thing only in terms of sine of presumably sine of x, only sine of x. So that's easy because I write this thing as cosine of x plus root 3 sine of x plus x. And we know how to do this. Is cosine x minus sine x sine x. Remember the formula for cosine of the sum of two angles looks like that, plus root 3. And here we have sine of sum of two angles, sine x cos x plus cos x sine x. Okay, there we are. Now this is going to be cos squared x minus sine squared x plus root 3. And these are the same thing. So we go 2 sine x cos x. If you want only sine of x, so this is, we can write this as 1 minus sine squared x. That's what this thing is. This is this minus sine squared x plus root 3, 2 times root 3 sine x. Now that one, if I don't want cosine, I can write it as 1 minus sine squared x. Okay, so clean it up. 1 minus these two add up, 2 sine squared x plus 2 root 3 sine x root of 1 minus sine squared x. Notice that g of x is entirely in terms of sine of x. Now I'm not going to plot it. If you want, you can do that yourself. Same thing here. This one is number 60. Same story. F of x equal to sine x plus cos x. Okay, sine x plus cos x. Well, the different ways of interpreting this thing. One is to, if you want everything, because the problem is vague, you know, I can say that this is sine of x plus. Let me stop this. So this was number 60. F of x equal to sine x plus cos x. Now, this problem is just like the other one. Maybe it's also vague because maybe this is not what you can do this. See that? This is entirely in terms of sine of x. But this is not what they want in the present section, because in the present section, they want you to use the formulas for a sum of sine of the sum of two angles difference. So what I'm going to do is I'm going to do this thing, look at it differently. So sine of x times, for example, I'll write this thing as a cosine of let me see now. How about cosine of 2 pi? Okay, cosine of 2 pi is 1, right? Plus, oh, this is not going to work. So let me see what they might have in mind. Okay, so I'm going to write it like this. Sine of x root 2 over 2 plus cosine of x root 2 over 2 times this. Okay. Of course, this is not correct. This is not correct. These are not equal to each other. So I have to put 2 over root 2 here so that they do become equal to each other. So 2 over root 2. Now this is sine of x cosine of pi over 4 plus cosine of x sine of pi over 4. And now we have a formula which allows us to combine these things. This is sine of x plus pi over 4. My guess is that this problem, they expected you to do it like so, not using the standard thing that's up there, okay? I mean, it's not a big deal because the problem is vague. There are many ways of doing this, and that's okay. At least it gives you a practice on how these formulas work, whatever you learned in this section. 61, it says let g of x be equal to cosine of x, show or prove, very word, that g of x plus h g of x plus h minus g of x divided by h is equal to minus cosine of x times 1 minus cosine of h divided by h minus sine of x sine of h over h. This is the kind of thing that's going to come up in your calculus class. So that's why they want you to manipulate it. That's really all. Left-hand side is equal to, well, it's going to be g cosine of x plus h, right? Because if g of x is cosine of x, g of x plus h is cosine of x plus h minus minus cosine of x divided by h. Clean it up so we can expand this. It's going to be cos x cos h minus sine x sine h minus cos x divided by h. Okay, so this is basically a simple algebra. I took grouped these two, so I write like that: cos x cos h minus cos x. I'll keep it together, and these two I'll keep together. This should be h. This should be h. Yeah. Divided by h. We're almost done. These two have a common factor of cos of x. So it's going to be cos h minus 1. This whole thing divided by h minus sine x sine h. I do this minus that, standard trick, cos x, cos h minus 1 over h minus sine x, sine h over h, and finally rewrite this thing as cos of x times cos of h minus 1 divided by h minus sine x, sine h over h. And this is exactly what your right hand side is, right there. You see this? Oh, the only thing is that they have factored, I see that they have factored a minus out of that expression. Okay, so what they did here is they did it like this. They took a factor of 1 minus out, so it's going to be minus cos x, 1 minus cos h divided by h, and then the rest stays, sine x, sine h over h, which is exactly the right hand side. This is it. Please practice.